I'm going to be answering WAEC 2019 chemistry objective past questions, and this is question number 2. The question is: a solid substance with high melting point and boiling point is likely to be A. a covalent bonding, B. additive bonding, C. an electrovalent compound, or D. a non-metal. So what they want you to consider in this question is what type of the bond that the atoms or molecules that forms this substance they speak of, possesses. In other words, they are asking you, or the question they are trying to ask you is, this exact substance, this solid substance with high melting and boiling points, what type of bond exists between its components or constituent atoms and molecules? So the options, I would be breaking down the options, and then we would select or choose the answer or see the answer. Option A is a covalent bond. Now, a covalent bond is basically a kind of chemical bond that involves sharing of electron pairs between atoms. So any type of bond where basically you have the electrons being shared in order for both constituent atoms to achieve their neutral states, or octet or duplet states rather, as the case may be. That sort of bond is a covalent bond. A popular example is a water molecule, in which each hydrogen atom shares an electron with the oxygen atom. So the other option is option B, which is a dative bond. Now, in a dative bond can also be referred to as a coordinate covalent bond, and it's a kind of covalent bond in which the electrons that are to be shared are derived from one of the constituent atoms. So, for example, in a phosphate molecule, you have phosphorus, the phosphorus atom, or the supplying the three supplying the three electrons that are going to be shared, or that will be shared with the three oxygen atoms, in order to to achieve that state, the ideal state. And C is an electrovalent compound. Now, an electrovalent compound, of course, is a kind of compound, or basically an electrovalent compound is a compound that comprises of atoms that are bonded together by an electrovalent bond. And for electrovalent bonds are formed by positive and negative, positively and negatively charged atoms. So, or which are ions, because being charged. So these electrovalent bonds usually are stronger than covalent and dative bonds because of that strong force of attraction, that strong attractive force between the positive and negative ions that make up the compound. So electrovalent compounds usually have, or usually possess, strong electrovalent bonds. Now, for non-metals, of course, non-metals are basically elements, or found elements on the periodic table that require electrons, that receive electrons to achieve octet or duplet state. So from the explanation I have just given, the answer to the question is C, which is electrovalent compound. Now, I have earlier stated that electrovalent compounds, have very strong electrovalent bonds among their constituent atoms. So, due to these strong bonds between the constituent substances, constituent atoms, their melting points and boiling points are usually high due to these strong electrovalent bonds, and they are mostly solids. So that's an important fact to note. They are also, or mostly, solid. So electrovalent compound is the answer to the question. Please subscribe to the YouTube channel for more videos. Thank you. Hello, I will be answering WAEC 2019 Chemistry Objective Past Question 3. And the question is, which of the following metals reacts slowly to cold water? A. Iron, B. Silver, C. Calcium, and D. Potassium. Now, metal reactions with cold water, or the way metals react on exposure to cold water, is a very important aspect basically in chemistry, and it's important to note which elements, which metals react to cold water and the manner in which they react. Do they react violently, or do they react slowly and much less violently than the other elements? So going straight to the point, uh, sodium reacts fastest and very violently with cold water. It is known for that property. It's a well-known chemical property of sodium. It reacts very quickly and somewhat violently with cold water. However, sodium is not on the options given to us. So I'm just stating that as it's important to know it's a very common property. And then we have, from the options given to us, first we have iron. Now, iron does not, basically there is no exact known reaction. Iron is not known for its reaction to cold water, neither is silver. But calcium and potassium are known to react with cold water. Now, potassium reacts with cold water very vigorously. It reacts very vigorously with cold water. And then calcium also reacts with cold water, but much less slowly than potassium. So a good way to ascertain this, or to deduce this, would be via the electropositive series. Now, the electropositive series arranges metals according to their reactivity. So on the electropositive series, first you have potassium, followed by sodium, and then calcium, followed by magnesium, then aluminium, then zinc, then iron, then tin, then dubnium. In case you are unfamiliar with it, it is element 105, then hydrogen, then copper, then mercury, followed by silver, and finally gold. So this is what the electropositive series looks like. Now, potassium, sodium, and calcium are known for their reactions with cold water. Like I said, potassium reacts violently, very violently, and very fast, vigorously with cold water. Sodium also reacts considerably fast, and then calcium reacts slowly to cold water. So as you progress down the electropositive series, the the quickness of the reaction with cold water decreases until you get to a point, I think around aluminium, zinc, where reaction is negligible to non-existent. So the answer, as I've stated, is calcium, which is C. And calcium, like we said, reacts slowly to cold water. Please subscribe to our YouTube channel for more videos and more past question answers and solutions. Thank you. Hello, I'll be answering WAEC 2019 Chemistry Objective Past Question 4. And the question is, which of the following elements has the highest ionization energy? A. Calcium, B. Fluorine, C. Chloride, and D. Magnesium. Now, ionization energy is one of the properties or characteristics that elements or atoms on the periodic table exhibit, and ionization energy refers to the amount of energy required to remove an electron from each atom in a mole of gaseous atoms, producing 1 mole of gaseous ions with positive charge. Now let me break it down. Basically, ionization energy is the amount of energy that an atom requires to remove an electron, right? To remove 1 electron from its outermost shell from each atom, from each of the atoms in a mole contained, from each of the atoms contained in 1 mole of gaseous atoms. So the energy required by, the amount of energy required by an atom to remove 1 electron, to remove an electron from each atom in 1 mole of the gaseous atom is referred to as ionization energy. Now, an important fact to note is that the more electropositive an element is, or the atom of an element is, the higher the tendency it is to lose an electron, because electropositive atoms are majorly metals, and basically metals are known as electron donors in reactions. So what I just said basically in simpler terms means that an electropositive atom or an atom of a metal is much more likely to lose electrons than much more electronegative atoms. So looking at the options here, you have calcium, which is basically a metal. You have fluorine, which is a highly reactive non-metal. You have chlorine, which is also another non-metal, and then you have magnesium, which is also a metal. So calcium and magnesium are metals, and because they are metals, they require lower energy. The energy required for them to remove electrons is lower, so they are ruled out of possibly being the answer, because the question is asking which one has highest ionization energy. Now we'll look at fluorine and chlorine. Fluorine is much more reactive than chlorine, and therefore the answer is B. Fluorine is a much more reactive non-metal than chlorine, so the answer is fluorine. I'll be answering WAEC 2019 Chemistry Objective Past Question 5. And the question is, the bleaching action of chlorine is through the process of A. Hydration, B. Hydrolysis, C. Reduction, and D. Oxidation. Now, it's important to note that the bleaching action of chlorine is one of the most important actions, chemical properties, or in fact one of the most common questions asked under chlorine. And the bleaching action of chlorine is basically through the process of oxidation. Now, oxidation is option D, which is the answer to the question. Now, most bleaching agents out there make use of this mechanism or this bleaching action of chlorine in order to carry out their functions. So how exactly does this mechanism occur? The bleaching action of chlorine is based on oxidation. Now, when chlorine is exposed to water in general, when chlorine is exposed to water, it reacts with water, and the products formed are hydrochloric acid and hypochlorous acid. Now, hypochlorous acid further disintegrates due to the fact that it is very unstable. So hypochlorous acid disintegrates into hydrochloric acid and oxygen. Now, this oxygen atom is the one that reacts with the colored material. So you have the colored material reacting with oxygen, and when this reaction occurs, the colored material becomes colorless. In other words, it's bleached. So this is the mechanism that works for removal of stains as well, because basically stains are colored material, and trying to remove stain will involve using a bleaching agent, one of which, or most of which make use of the bleaching action of chlorine, or make use of chlorine as one of their constituent products to remove stains, which are basically just colored materials, or to turn them colorless. So that is the bleaching action of chlorine. That is the mechanism of how chlorine functions to remove stains and colored or colors. So endeavor to subscribe to this YouTube channel for more videos and also more past questions and answers. Thank you. I'm going to be answering WAEC 2019 chemistry objective past questions, and this is question number 7. And the question is, calcium and magnesium belong to the same group in the periodic table because both A are metals, B form caution, C form colorless salts, D have same number of valence electrons. Now, the first thing you require to answer this question is the atomic number of calcium and magnesium respectively. So for calcium, the atomic number is 20, and for magnesium, atomic number 12. So once you have gotten once you've established the atomic numbers for both calcium and magnesium, the next will be to determine each electronic configuration, the electronic configuration of calcium and magnesium in the KLMNO format. So, as you may know, the KLMNO format expresses the number of electrons in each shell of the atom. So, for calcium, the electronic configuration will be 2, 8, 8, 2. The reason is because the innermost shell, the K shell, can take a maximum of 2 electrons. So you have 2 electrons in the K shell. Then L, M, N can take 8 electrons, can take a maximum of 8 electrons, can each take a maximum of 8 electrons. So L for calcium takes 8, M takes 8, and then N, which is the outermost shell in a calcium atom has 2 electrons. So for magnesium, the configuration will be 2, 8, 2. On the K shell, you have 2 electrons. On the L shell, you have 8, which is the maximum number you can take. And then for the outermost shell, which is the M shell for magnesium, it has just 2 electrons here. So you would notice that if you add the numbers here, 2 plus 8 plus 8 plus 2 is 20, which is the atomic number for calcium. So atomic number, as you may know, is also the number of electrons as well as number of protons, because an atom is neutrally charged, and magnesium, if you add the number here, 2 plus 8 plus 2, it will give you 12. So which is also the atomic number of magnesium. So once as you establish the atomic numbers of both calcium and magnesium, notice that we have both calcium and magnesium have 2 electrons on the outermost shell. Now these electrons on the outermost shell, the electrons on the outermost shell are what are known as the valence electrons. And these valence electrons are the ones that are involved in formation of chemical compounds, or generally involved in chemical reactions. So the number of valence electrons also tells us what group each element belongs to. So since both calcium and magnesium have 2 valence electrons, they belong to the same group. So the answer is D, as we have rightly established. So we can now see the reason why both calcium and magnesium belong to the same group, and that reason is because they both have the same number of valence electrons, or the same number of electrons on the outermost shell. Please subscribe to the YouTube channel, our YouTube channel, for more videos and also for more past questions and answers. Thank you.
Sometimes I have to spend hours before translate what is in JavaScript to Java.
Okay, but his ideas can be used in Java.
We're going to be answering WAEC 2019 Chemistry Objective Past Question.
But is there any
This is
better
question
person?
number 8. The question is, which of the following substance is non-polar? A. Bromine. B. Ammonia. C. Water. And D. Hydrogen bromide. Which of the following substance is non-polar? A. Bromine. B. Ammonia. C. Water. And D. Hydrogen bromide. So to answer this question, the first question you would ask yourself is, what exactly is a non-polar compound, or what is a non-polar substance? And if you have non-polar substances, then chances are there are also polar substances. So what is a polar substance and what is a non-polar substance? Now, I'll start from a polar substance. A polar substance or compound is any substance or any compound that has slight charges within that particular compound. A polar compound possesses charges within the constituents that make up that particular compound, and those charges exist due to electronegativity. And electronegativity is the attraction of an element, or the the tendency for an element to attract
So
electrons.
this one, do you
So
have to read all these basic
polar
knowledge?
substances
Yeah,
basically
maybe
are compounds, or examples of polar substances or polar compounds are
follow the pattern. Because that pattern set what I
water,
like. These three, like this, like
hydrochloric acid,
yeah, that is
ammonia,
sometimes there's this
etc. Now,
food.
these substances or these compounds possess charges within them, and the charges that they possess within them are due to the tendency for them to attract electrons. That is electronegativity. Now, as for nonpolar compounds or nonpolar substances are the
Just
direct
study all the
opposite
master
of
to use to
polar substances.
study it, then go back to where
And nonpolar substances, basically, just for sake of clarity, are compounds that do not possess charges within them. And usually, they are diatomic molecules. Most nonpolar substances are diatomic molecules.
this thing now, where
Other examples of
you say
nonpolar
all these things,
compounds include hydrocarbons such as benzene, carbon dioxide is also an example of a nonpolar substance, and then all the noble gases. The noble gases, examples of which are helium, neon, are nonpolar substances or nonpolar compounds. Nonpolar substances would be a more appropriate name to call them. Now remember that I also mentioned that diatomic molecules, that diatomic molecules are also examples of nonpolar substances. So from the options, you have bromine, ammonia, water, and hydrogen bromide. Now, if you look at ammonia, we have already mentioned ammonia as an example of a polar substance. So ammonia is ruled out. We've mentioned water also as an example of polar substance. So water is ruled out. Hydrogen bromide is a compound, a chemical compound that comprises of hydrogen and bromine. So since it is likely to possess charges within it, so hydrogen bromide is ruled out. But bromine, this is bromine, and bromine is a gas, and you agree with me that most gases exist as diatomic molecules, exist independently as diatomic molecules, like hydrogen. Hydrogen is a gas, so hydrogen exists independently this way as a diatomic molecule. So bromine is a diatomic molecule, and we listed diatomic molecules as examples of nonpolar substances. So the answer would be A, bromine. So bromine is a non-polar substance. Please subscribe to our YouTube channel for more videos and more past questions and answers. Thank you. Hello. We're going to be answering WAEC 2019 Chemistry Objective Past Questions. And this is question 9. Which of the following pair of components belongs to the same molecular mass? A. Ethene and ethyne. B. Ethane and ethene. C. Carbon 2 oxide and ethene. D. Carbon 4 oxide and ethyne. So the first step will be to write down the chemical formulae of each of the compounds given to us. So for ethene, the chemical formula is C2H4. So this is ethene. So we have ethyne. chemical symbol C2H2. We have ethane, chemical formula C2H6. We have carbon dioxide, carbon 2 oxide, carbon 2 oxide or carbon monoxide, carbon 2 oxide, CO, then we have carbon 4 oxide or carbon dioxide, which is CO2. So the first option A is ethene and ethyne. So we can see that ethene has 2 carbon atoms and 4 hydrogen atoms, and ethyne has 2 carbon atoms and 2 hydrogen atoms. So mathematically it's impossible for them to have the same molecular mass. So option A is ruled out. And then B is ethane and ethene. Similarly, they both have different number of hydrogen atoms. So mathematically it would be impossible for them to have the same molecular mass. So we'll be looking at option C, which is carbon 2 oxide. Now carbon 2 oxide, from the figures given to us, we can calculate its molecular mass, which is 12 plus 16. That is 1 atom of carbon and 1 oxygen atom. So 12 plus 16 is 28. Then ethene, which we'll also be looking at. Ethene has 2 carbon atoms, so 12 multiplied by 2 plus 1 multiplied by 4. 12 multiplied by 2 is 24. 1 multiplied by 4 is 4. So 24 plus 4 is 28. Now, carbon 4 oxide, 12 plus 16 multiplied by 2. Now 16 multiplied by 2 is 32, and 32 plus 12 is 44. And then ethyne, C2H2, which is 12 multiplied by 2 plus 1 multiplied by 2. So 12 multiplied by 2 is 24 plus 1 multiplied by 2, which is 2. So 24 plus 24 plus 2 is 26. So from this we can see that ethene has a molecular mass of 28 and carbon 2 oxide has a molecular mass of 28. So our answer will be C, which is carbon 2 oxide and ethene. So please subscribe to our YouTube channel, subscribe to this YouTube channel for more videos and also for more past question and answer. Hello, I'm going to be answering WAEC 2019 Chemistry Objective Past Question, and this is question 10. When an equilibrium is established between dissolved and undissolved solute, the solution is said to be A. Saturated, B. Unsaturated, C. Concentrated, and D. Diluted. So the first thing I would like to establish is that a solution is made up of 2 parts or 2 components, a solute and a solvent. Now in any topic considering in solubility generally, the solute is the solid component. And the solvent is usually the liquid component. So if you have a solution of salts and water, which is sodium chloride and water, the sodium chloride is the solute and the water is the solvent. So for a saturated solution, unsaturated solution, concentrated solution, and diluted solution, the definition of these terms each depend on the amount of solutes you have in the solvent. So for a saturated solution contains the maximum amount of solutes that the solvent is capable of dissolving. So when a solvent contains the highest number of solutes that it is capable of dissolving, that solution, the solution formed, is said to be a saturated solution. For example, if you have, let's say, at a particular temperature, you have, let's say, a liter of water, and you dissolve 36 grams, for example, of sodium chloride in it. If you can no longer dissolve more solute, more sodium chloride in that 1 liter of water after putting 36 grams of sodium chloride, the solution is said to be saturated at that particular point. So you can express it by saying 36 grams of sodium chloride is enough to saturate 1 liter of water at any given or at a particular temperature, let's say 25 degrees or 25 degrees Celsius or any other, a hypothetical temperature. So for an unsaturated solution, the amount of solute that is present in the solution or that is present in the solvent or that has been dissolved in the solvent is less than the maximum amount of solute that the solvent is capable of dissolving. So let's use the same as sodium chloride and water instance. Now, if we have established the fact that 36 grams of sodium chloride is enough to saturate 1 liter of water, if you have less than 36 grams of sodium chloride in 1 liter of water, then it can be said that the solution you have is unsaturated, because the amount of solutes that you have in that water, in that solvent, is less than the maximum amount that can be dissolved. So in that instance, the solution is said to be unsaturated. Then for a concentrated solution is one that contains relatively large amounts of dissolved solutes. So if, let's say, in 1 liter of water also, for example, you dissolve a large amount of solute, let's say the solute is sugar. So if you dissolve a considerably large amount of sugar in 1 liter of water, the solution can be said to be concentrated. Let's say you dissolve, 30 grams of sugar in 1 liter. The solution can be said to be concentrated. Then for a diluted solution, you have relatively small amount of dissolved solution. So for example, in this same sugar and water instance, let's say you dissolve just 1 gram of sugar in 1 liter of water, the solution can be said to be diluted. Now, one thing I didn't mention is that in a saturated solution, the dissolved solute is in equilibrium with the undissolved solute, because the solvent is incapable of dissolving more solute. So there's an equilibrium established between the dissolved solute and the undissolved solute, and no dissolution will take place again. It doesn't matter how much more solid to put into the solvent or the solution in this case, the no more solute is going to dissolve. So for this reason, an equilibrium has been established between dissolved solutes and the undissolved solutes. So when an equilibrium is established between dissolved and undissolved solutes, the solution will then be said to be saturated, which is A, and it's our answer. So please subscribe to this YouTube channel. I'm going to be solving WAEC 2019 chemistry objective past question, and this is number 11. And the question is, how many moles of carbon dioxide contains 16.0 grams of oxygen? A. 0.20 mole, B. 0.25 mole, C. 0.40 mole, D. 0.50 mole. Now, the first fact you need to establish is that 1 mole of oxygen is contained in 1 mole of carbon dioxide. So I need you to just remember that fact. Next, we need to determine the number of mole of oxygen present in 16 grams of oxygen. So how many moles is present in 16 grams of oxygen? So number of mole is equal to mass over molar mass. Now the mass we are considering is 16 grams, and the molar mass is 16 multiplied by 2, because there are 2 atoms of oxygen present in a molecule of oxygen, as seen here, O2. So 16 over 32, which is equal to 0.5 mole. Now remember, we established the fact that 1 mole of oxygen is contained in 1 mole of carbon dioxide. So how many mole of oxygen? 0.5 mole of oxygen is contained in how many moles of carbon dioxide? So if you do a cross multiplication, you would have this way, which is x multiplied by 1, that is x. So x will be equal to 0.5 multiplied by 1, which is 0.5. So our answer is 0.5 mole of carbon dioxide. So our answer is D, 0.5 mole of carbon dioxide. So 0.5, D is our answer. So please subscribe to this channel for more videos and for more past questions and answers. Thank you. Hello, welcome to WAEC 2019 Chemistry Objective Past Questions, and this is question 12. Stoichiometry is based on the law of A. Multiple proportion, B. Constant composition, C. Conservation of energy, D. Conservation of mass. Now, to answer this question, I will first define stoichiometry. Stoichiometry is the relationship between the relative quantity of substances taking part in a reaction. The relationship between the quantities of substances taking part in a reaction, in a chemical reaction. So in order to answer this question, we need to define each of the options to see which one is closest, or to see which one gives us an idea on what stoichiometry is all about. Now, the law of multiple proportion. Multiple proportion, like I said, it's a law. So multiple proportion states that if two or more elements form more than one compound, form more than one chemical compound, the ratio of the masses of the second element which is element 2, and a fixed mass of element 1 will always be ratios of small numbers. Next, let's look at the law of constant composition. Now, in the law of constant composition, a given chemical compound will always contain its component elements in fixed ratio. Will always contain its elements in fixed ratio. Now, for the law of conservation of energy, energy can neither be created nor destroyed.
Next.
And lastly, for the conservation of mass, the total reacting mass of compounds involved in a reaction is equal to the total mass after the reaction. So, in stoichiometry is an aspect of chemistry that is based on measurement of masses, comparing the masses between products and reactants, as we rightly established that this is the relationship between quantities of substances taking part in a reaction. So from this, the law that is given to us amongst the options that talks about masses of components in a reaction being equal to before and after a reaction, or being equal to each other before and after a reaction, is the law of conservation of mass, which is the answer to this question. So please subscribe to this YouTube channel for more past questions and answers, and for more videos. And welcome to WAEC 2019 Chemistry Past Questions. I'll be answering question number 13. The question is, what percentage by mass of hydrogen is present in CH3COO3, which is ethanoic acid? A, 1.7%, B, 5.0%, C, 6.7%, D, 7.1%. Now, in order to solve this question, you need to first find the total mass of the element you are looking for. That is the total. You have to first of all find the total mass of hydrogen and divide it by the molar mass of this compound. So you find the total mass of hydrogen in this compound and then divide it by the molar mass of this compound. So in this compound you have 3 molecules of hydrogen plus 1, that is 4 atoms rather of hydrogen. Now, percentage by mass of hydrogen is equal to total mass of hydrogen divided by molar mass of ethanoic acid. Now, the total mass of hydrogen, the atomic mass of hydrogen is 1, and you have 4 atoms of hydrogen in this compound. So you have 3 here and 1 here. So that is 1 multiplied by 4 divided by the molar mass of ethanoic acid, which is 60, which has been given to us here. So 4 over 60 is equal to 6.67. Now remember that this is in percentage, so 6.67% is our final answer, and 6.67% is approximately 6.7%, and that is option C, which is the answer to this question. So please subscribe to this YouTube channel for more videos and for more past questions and answers. I'm going to be answering WAEC 2019 chemistry past questions, and this is question number 14. And the question is, which of the following substance has coordinated bonding in its structure? A. Aluminium chloride. B. Sodium chloride. C. Silver chloride. D. Magnesium chloride. Now, first let us define what a coordinate bond is, or we need to know what coordinated bonding is. So, what is a coordinate bond? A coordinate bond basically refers to a special type of covalent bond where only one atom donates the electrons to be shared in the chemical reaction. Now that we've established what coordinate bonding is, the first option is aluminium chloride, made up of 2 atoms of aluminium and 6 atoms of chlorine. Now structurally, you would have, let me illustrate it. You have aluminium atoms, 2 in number. So aluminium has 3 electrons on its outermost shell. So let's assume this structure I've just drawn is the outermost shell of aluminium. So you have 3 electrons on it. So you have 2 of that. Three electrons on the outermost shell. And then for chlorine has 7 electrons on its outermost shell. So let's illustrate that. So three, 4, 5, 6, 7. So you have 6 of it. Now for sodium chloride, you have 1 sodium atom and 1 chloride or 1 chlorine atom. Now the chlorine atom, of course, as we have said, has 7 on its outermost shell, 7 electrons on its outermost shell, while sodium has 1 electron on its outermost shell. Now silver also has 1 electron on its outermost shell in silver chloride. So silver has just 1 electron on its outermost shell, and it combines with a chloride ion, like with 7 on its outermost shell, 7 electrons on its outermost shell. Magnesium chloride. Magnesium has 2 electrons on its outermost shell. So let's take this to be our magnesium with 2 electrons on its outermost shell. Now it combines with two chloride or 2 chlorine atoms that have 7 electrons each on their outermost shell. So that is it. Now, the first thing we have to notice that, or we have to rule out, is that from the way it looks, sodium chloride and silver chloride cannot be under coordinate bonding, because looking at the structures of the atoms, what happens here is electrovalent bonding, because sodium and silver respectively will donate their valence electron to chlorine in order to form the product. As for magnesium chloride will share magnesium chloride will donate 2 of its valence electrons to the 2 chlorine atoms. So that is also electrovalent bond. So magnesium chloride, all of them, this and this, are all electrovalent bonds that are formed. Now, looking at this, the only one which is not an electrovalent bond is option A, which is aluminium chloride. Now, in the aluminium chloride structure, the aluminium ion will the 2 aluminium atoms each will give 1 atom to each. We share 1 atom to each of the 6 chloride ions, creating or forming the product. So, for example, you have each aluminium atom has 3 valence electrons, 1, 2, 3. So you have another aluminium with 1, 2, 3. So those 3, and you have 6 chloride. So you have 6 chlorine atoms to receive electrons. So they will be shared, and all will come from the aluminium. All will come from the 2 aluminium atoms. So this aluminium atom will share with 3 of the chlorine atoms, and these 3 will share with the remaining 3 chlorine atoms. So the answer is A, which is aluminium chloride. So please subscribe to the YouTube channel and view more past questions and answers, and also more videos. Thank you. Hello, I'm going to be answering WAEC 2019 chemistry past questions, and this is number 15. The name of the compound, so you have this compound structure, the structure of the compound given to you here, is A. 2-methylbutane, B. 2,2-dimethylbutane, C. 2-methylpentane, D. 2,2-dimethylpentane. Now, in order to name the compound properly, you will need to represent or rewrite this structure in a better form that will enable you name the compound. Now, to write that structure, first you count the number of carbon atoms you have in the main structure. So you won't count this one in the brackets, just the one outside, the carbon atoms you have outside. So you have 1, 2, 3, 4, 5 carbon atoms. So you write it this way: 1, 2, 3, 4, 5 carbon atoms. So you have 5 carbon atoms here. Now, you begin then to add the hydrogen atoms and every other functional group that is present here. So to the first carbon, you have 3 hydrogen atoms. So this is the first, this is the second, and this is the third. Now, for the second carbon atom, you have a methyl group, so CH3, right there. Then, so the methyl groups are 2, as you can see here, CH3 in bracket, then 2. So there are 2 methyl groups. So you add the second methyl group here. Then CH2 is next. So you have 2 hydrogen atoms here. So 1 here and 1 up here. Then for the fourth, you also have 2 hydrogen atoms, represented this way. For the fifth, you have 3. So this, 3 hydrogen atoms. Now that we have represented it in this structure, the next thing we'll do is to name it. How do you name an organic compound? First, you count the number of carbon atoms, starting from the carbon atom closest to the functional group. So this is carbon atom 1, this is 2, this is 3, this is 4, this is 5. And it is an alkane because there is no double bond or triple bond. It's all single bonds linking each of the carbon atoms. So that then means that, and since you have 5 carbon atoms, it means the name will end in pentane, which is 5 carbon atoms. Now, next thing you will do is the carbon atom where you have the functional group, to the carbon atom where you have the functional group, you determine which functional group is attached to that carbon atom. So the functional group you have there is methyl, and you have 2 methyl attached to the carbon. So the carbon is the second carbon, and both methyl groups are attached to the second carbon. So that will be 2, 2, because you have 2 methyl groups attached to the carbon atom. Di, of course, di standing for 2, dimethyl pentane, 2, 2 dimethyl pentane, and the answer to that is D. So that is the answer to this question and how to name an organic compound. So please subscribe to this YouTube channel for more past question and answers and for more videos. Thank you. I'm going to be answering WAEC 2019 chemistry past question, and this is question 16. The properties of a good primary standard include the following except A. High molecular mass, B. Low molecular mass, C. High degree of purity, D. Readily available. Now first I'll define what a primary standard is. A primary standard is a chemical reagent that has high purity and is sufficiently accurate such that it is not calibrated by another reagent. Now, what are the properties of a good primary standard? We will look at the options and define each of them one after the other in order to see how each of them affects a standard or affects a primary standard. Now, high molecular mass. High molecular mass is important because a primary standard needs to have a relatively high molecular mass that allows them to be easily measured. Now, a high molecular mass enables the primary standard to be easily measured and accurately weighed without or with minimal error. Now, low molecular mass. The low molecular mass, of course, is opposite of high molecular mass. And if it is opposite of high molecular mass, it means that there will be difficulty in measurement. High degree of purity. For high degree of purity, the primary standard must have a sufficiently high degree of purity such that calibration is not needed. And lastly, readily available. Of course, a good primary standard must be available, readily, must easily be obtained without difficulty. Now, examples of primary standards include sodium chloride, zinc powder, sodium oxalate, which is NaC2O4, etc. Now, from the definitions we are given, we see that low molecular mass will make the standard to be difficult in measuring. Therefore, low molecular mass is not a good property for a primary standard to have, and therefore the answer is B, low molecular mass. Please subscribe to this YouTube channel for more past questions and answers, and also for more videos. Thank you. I'm going to be answering WAEC 2019 Chemistry Objective Past Question 17. What is the solubility of a salt X at 25 degrees Celsius if the standard solution of the salt